Okay, we're on lesson 28 of pre-calculus. It's unit 5-6 in the pre-calculus book, page 313, the law of sines. Now, what we've done so far, we're gonna do a little bit of review at the first of this. Long ago in junior high, you learned that in a right triangle, the side across from the right angle is C. The sides that make the right angle are A and B, and we learned the Pythagorean theorem that said a squared plus b squared is equal to c squared. And so we began to solve right triangles. And then later on, we got into geometry. And in geometry, we learned some special right triangles. We learned about a 30, 60, 90 triangle. And we said that the legs are in the sides are in the ratio of 1 to 2 to the square root of 3. And if we have similar triangles, all we're doing is enlarging, but the shape's the same. So the sides are in proportion. And those proportions would reduce back down to that simplified ratio 1, 2, and the square root of 3. And we learned about another special right triangle that we're going to use a lot, and that was 45, 45, 90 triangles. And we said in 45, 45, 90 triangles, the legs are equal, and the length of the hypotenuse is equal to the length of a leg times the square root of 2. So we were solving right triangles by finding a missing side. We couldn't find the missing angles, just the missing side, using Pythagorean theorem. And then we got into special right triangles, 30, 60, 90, 45, 45, 90. And we could find some more stuff that we couldn't find when it was just a plain old right triangle. But then we said, well, what if it's not 30, 60, 90, or 45, 45, 90, but it's still a right triangle? We said then, well, if we call X, and we call this A, and well, let's just call it ABC again. If we had a right triangle like this, and we called this angle C, we'd call that little c, and if we called this angle A, we would call that little a. If we called this angle B, we could call that little b. And we could set up a sine ratio by saying that the sine of angle A is equal to the length of the leg opposite A over the hypotenuse C. And we could say that the cosine of that angle A is equal to the length of the leg adjacent to that angle B over the hypotenuse C. And we could say that the tangent of that angle A is equal to the length of the leg opposite that angle A, which is A, over the length of the leg adjacent B. And so then we could find missing sides and angles of right triangles whose angles were not 30, 60, or 45. And so we was able to do some more stuff. Well, that's what we can do so far with triangles. Now, notice the common thing about all of these. What's common about all of these? They're all right triangles. Well, the next thing, we can do just about anything we want to now with a right triangle, with just a little bitty bit of information. So the next question would be, well, what if it's not a right triangle? Can we find missing parts of non-right triangles? And the way we find missing parts of non-right triangles is with the law of sines and the law of cosines. Now we're going to start with the law of sines. In geometry, we learned things like this. Let's just play with this for just a little bit. Let's say we had something marked here and something marked there and something marked there. And we were talking about either congruency or similarity. What would we call that? Side, very next angle, very next side. So you kind of learned how to look at how those were marked, or what was given, a side, very next angle, very next side. Or we may have seen something like this, and it may have been marked like this. And we said, well, I've got an angle and the very next side and the very next angle, and so we recognize that as being angle, side, angle. And then we may have had something like this, where we had this and this and this, and we said, okay, we've got an angle, the very next angle, and the very next side, so we would have called that angle, angle, side. But it actually said it fancy in the geometry book. In the geometry book, it said this, and this is kind of important to know. It would say two sides and the included angle, the angle that was included between those two sides. Or we would say two angles and the included side. Or we would say two angles and a non-included side. Remember that terminology, two angles and an included side, two angles and a non-included side. But it's kind of the way you read it. Angle, very next angle, very next side, angle, very next side, very next angle, side, very next angle, very next side. So if you say the very next, you kind of got it, okay? That's going to become important with the law of sines and cosines. All right. So I'm going to clean the bottom half of this stuff out right quick. So let me get rid of all of that. That was just to kind of get us started. There we go. Okay. Now, in a triangle, even if it's a non-right triangle, we're still going to, in a non-right triangle, I'm going to make an obtuse triangle. We're still going to call the side opposite C little c, and the side opposite angle A little a, and the side B little b. We're still going to do that, okay? Even in a non-right triangle. We just can't call C the hypotenuse and A and B the legs, okay? Now, the law of sines works when what you're given is in the order angle, angle, side, or angle, side, angle. This is important. The law of sines works in a non-right triangle when what you're given is in the order angle, angle, side, or angle, side, angle. Side, side, angle is less than 29, which is the ambiguous case for law of sines. So law of sines can also apply to side, side, angle, but it's an ambiguous case, and we have to really study it before we decide how to deal with it. So we're going to deal with the law of sines in the non-ambiguous cases, angle, angle, side, and angle, side, angle first. Okay, so let's just look at number one on the homework there. Number one says A is equal to 40 degrees. It says C is equal to 70 degrees. And it says that little a is equal to 20. And we want to solve the triangle. Now, if we're going to solve the triangle, we want to find angle A, angle B, angle C, little a, little b, and little c. We're going to find every little piece of this non-right triangle, okay? I understand what we're doing so far. Now, let's look at what we're given. I'm going to go ahead and write it in there. We're given angle A is 40 degrees. We're given that angle C is 70 degrees. And we're given that little a is 20. So what order is that in? It's in the order of angle, angle, side. What we're given is in the order angle, angle, side. And we're going to use the law of sines. Now, we haven't even written the law of sines down yet. Okay? Now, the law of sines is this. The law of sines says that the sine of angle A over little a is equal to the sine of angle B over little b, which is equal to the sine of angle C over little c. That is the law of sines, and you need to memorize it. In your textbook, it's going to have A over sine A, B over sine B, C over sine C. That's not the way I memorized it, so I'm putting the signs on top. It wouldn't matter. Sine angle A over little a equals sine angle B over little b equals sine angle C over little c, and you memorize that forever because it's a rule you're supposed to know. So we're going to plug into that. Now, the first thing we can do is go and write down what we know. Angle A is 40 degrees, and angle C is 70 degrees, and little a is 20. Now, what can we find quickly without using any fancy rules like the law of sines? Angle B. We can find angle B by taking 180 degrees minus my 40 minus my 70. I guess I'll just do it like that. Minus 40 degrees minus 70 degrees. And we're going to get what for angle B? 70 degrees, which means it's an isosceles triangle actually. But anyway, and so we get 70 degrees for angle B. Now, all we have to be able to do is set up a proportion with one missing piece, right? So if I want to find little b, then what I need is little b, angle A, and little a. I need all but one of those, right? So if I were to know angle A, angle B, and little a, I could actually find little b, because I would have 3 out of the 4 pieces of that proportion. And we know all of that stuff, so we can do that to find little b. So to find little b, we're gonna use this part of the law of sines. So we're gonna say sine of angle A, which is 40 degrees, over little a, which is 20, is equal to the sine of angle B, which is 70 degrees, over little b, which we don't know. And we have a proportion that we can solve. Any questions so far? So to solve, we're going to have b times sine 40, which we could write as either way. I'm going to write it as sine 40b, 40 degrees b, is equal to 20 sine 70 degrees. I'm solving for b. I'm not going to do any calculations till the very end. Now I want the junk off of b. Sine 40 is being multiplied to b, so I'm going to divide it off of b. So I'm going to divide by sine 40. And so I'm going to get b is equal to. So to get b, I do this. I do sine 70 divide sine 40. Stick that in the calculator and hit enter. If you do 20 sine 70 divide sine 40 and round to the nearest tenth, you get 29.2. And so little b is 29.2. 29.2. I'm going to ask you something on purpose. I would really like that to look like a decimal. I guess it doesn't matter if it does or not. If we know a and b, how can we get c? Pythagorean theorem. I knew somebody would say it. See, I tricked you. This is not a right triangle, right? You're going to want to use Pythagorean theorem, but you can't use Pythagorean theorem because these are non-right triangles. Okay, so don't make that mistake because you're going to want to, because we've been used to doing that. All right, so we're going to have to find c by using law of sines again because it's not a right triangle. Okay, so we're going to come over here and use this. We could use a again, right? We could use this and this if we wanted to. Or we could go back and use the b we have. So we're going to start again to find little c. So we're going to put sine of angle A, which is 40 degrees, over little a, which is 20, is equal to the sine of angle C, which is 70 degrees, over little c, which we don't know. Now, we do know, though, that angle C and angle B were the same. It's an isosceles triangle, and we know from geometry that sides opposite equal angles are equal. Remember that? So in this particular case, C is going to come out to be the same thing B is going to come out to be. And we could go ahead and solve this if we wanted to, but we already know the answer is 29.2. It's the same setup we had a while ago. So I'm not even going to go ahead and solve that. There's no need in it. If you want to solve it, you can. But we had the same setup we had with the first one. we know that if two angles of a triangle are equal, then the sides opposite those equal angles are equal. Any questions on number 1? So we solved the triangle, meaning we found every little missing piece. All right, I'm going to rewrite all of this so that we have a fresh slate for number 2. Now, I gave you two angle sides, but you realize, I'll show you something in just a second. I'm not necessarily drawing these to scale, you realize. That one, last one, was really out of whack. So we're going to call that C, little c, capital A, little a, capital B, little b. On number 2, what they gave us was little b is 12. They gave us that angle A is 25 degrees. And they gave us that angle B is 35 degrees. So we've got angle A is 25 degrees. Angle B is 35 degrees, which is obviously, angle B is 35 degrees. That's not so bad then. That wasn't nice at all. $35 degrees, if I can get it in there. And I've got a little b over here. And then little b was 12. Now, what they gave me is in the order of what? Angle. It's in the order angle. We got to go this way, right? Let me show you why. If I go this way, I have angle. Is the very next side marked? No. Is the very next angle marked? Yes, so I got angle. Is the very next side marked? Very next angle? The very next nothing was marked. I can't go that way. So I'm going to go the other way. Angle. Is the very next angle marked? Yes. Is the very next side marked? Yes. So I'm going to read it angle, side that way. See, you get the very next in there. If there's nothing very next, angle or side, you can't read it that way. All right. People have trouble with that in geometry when I'm teaching that. So angle, side. Now, you do know, though, we said angle, side, angle, or angle, side. You know if you know two angles of a triangle, you can find the third one. And if you use that, you'd have angle, side, angle, right? So if we just went ahead and found angle C, we would have angle, side, angle. If you got angle, side, you're going to have angle, side, angle because you already know two of them. You can find the third one because the sum of the angles of triangles is 180. Okay, so by default, we're going to kind of automatically have the other guy. All right, so we're going to find angle C, little a, little b, and little c. And they already told us that angle A was 25 degrees and angle B was 35 degrees and that little b was 12. How can we get angle C right quick? 180 minus 25 minus 35 is 110 degrees for angle C. 120 degrees for angle C. Thank you. My brain took it. 120 degrees. That's getting messy for video production, but it'll be okay. All right, any questions on that? So now we need little a and we need little c. So we're going to use the law of sines. The law of sines says that the sine of angle A over little a is equal to the sine of angle B over little b, which is equal to the sine of angle C over little c. If I'm looking for little a, then I have to have the thing with a in it. So I've got to have this one. Well, what am I going to put with it? Well, the one I know both of, right? What do I know both of? The b's. So I'm going to put that with the b because it's got both of them given, right? So I'm going to have sine A, which is 25 degrees, sine angle A, which is 25 degrees, over little a, which is what I'm looking for, is equal to sine B, which is 35 degrees, over little b, which is 12, and I have a proportion that I can solve. Let's see how I got that. To solve the proportion, we're going to cross multiply. So we're going to have 12 sine 25 degrees is equal to sine 35 degrees times a. So we cross multiply. 12 times sine 25 equal a times sine 35. We want the junk off of a, so I'm going to undo multiplication by division. So we're going to divide by sine 35. And we're going to get little a is equal to 12 sine 25 divide sine 35. If you put that in, you're going to get 8.8 for little a, rounded to the nearest tenth. Any questions on that? Again, you can't find c using the Pythagorean theorem because it's not a right triangle. This time, we don't have two angles equal, so that we could say sides opposite equal angles are equal, or angles opposite equal sides are equal. We're going to have to set up another ratio, proportion, and solve for c. It's the only way we're going to get c this time. And so we're going to take what we were given, the b stuff, with what we're looking for, little c, with the c stuff. And so we're going to have sine b, which is 35 degrees, over little b, which is 12, is equal to sine c, which is 120 degrees, over little c, which we don't know, and we have a proportion to solve for little c with. So to solve, we're going to cross multiply. We're going to have c times sine 35 is sine 35c is equal to 12 times sine 120. 12 sine 120. And then we're going to solve for c. We have sine 35 multiplied to the c. We're going to undo multiplication by division. So we divide both sides by sine 35 degrees. And we're going to get little c equal the answer to that. 12 sine 120 divide sine 35. And when you do that, you get 18.1 for little c. So this is how you use the law of sines to find missing sides or angles of a non-right triangle when what you're given is in the order angle, angle, side, or angle, side, angle. Any questions on that? Okay. The next little piece of the homework is finding the areas of non-right triangles. So we're going to do a little review of finding areas of triangles first and talk about what we've learned so far, and then we'll go from there to get into these new ways to find areas of stuff we could never find the area of before until we learned some stuff about the law of sines. I'm not proving these. I'm not going into the book and showing you the proof of all these rules. I could do that. I'm not going to do that. I'm just showing you how to use them. If you want to know why these are rules and where they came from, you can read the textbook and you can figure out why they're rules. You may or may not care why they're rules. Being able to use them is important, though. And so that at least we need to know how to do. All right, so we're on the law of sines lesson, but we're going to be dealing with areas of triangles. And so let's start with the basics and kind of work our way up as we look at what we've learned in the past. First of all, way back in junior high, you learned that the area of a triangle is 1/2 base times height. And the reason the area of a triangle is 1/2 base times height is because the area of a parallelogram base times height. And when we're talking about the base and height, we're talking about the bottom and how tall it is, which is the perpendicular segment from top to bottom. Since the area of a parallelogram is base times height, if we draw a diagonal in a parallelogram, we get a triangle that's half the area of the parallelogram. Therefore, the area of that triangle is half the area of the original parallelogram, so it's 1/2 base times height. Now, we began looking at triangles that would have a base and a height given, something nice like that. And then we said, okay, what if that's an acute triangle. And we said, well, what if I had a right triangle? If I have a right triangle, my base is one of the legs and the height's the other leg, because the legs are perpendicular. And then we said, well, what if I had a non-right triangle? What if I had an obtuse triangle and I called this the base? If I call that the base, where's the height? Straight down from top to bottom. In fact, the definition says that the altitude is a segment from a vertex perpendicular to the line that contains the opposite side. The base is that side of the triangle, and the height's out there somewhere. An auxiliary line, we call it. Okay? So we dealt with base and height of an acute triangle, base and height of a right triangle, base and height of a non-right triangle, if they gave you that information. But we're going to find out how in non-right triangles to find the area if we don't know the base and height. What if we just know some sides and some angles, but we don't know base and height? Well, we couldn't find it, but with a lot of trig and stuff, we can. Okay, so what we're going to be dealing with today, non-right triangles, and so we're going to find the area we are given what we're going to be given first is side angle side. And then in a minute, we're going to look at being given angle, angle, side. Okay. Now, let's draw a picture first. So let's just say that we had capital A, capital B, capital C, little a, little b, little c. Now, I'm going to use color. I'm going to try to do a decent job of showing you this. Side angle side. I could be given that side, that angle, and that side. You realize that? If I was given that side, that angle, and that side, then my area K. Now we're going to call area K so that we're not getting it confused with little a, okay? Is equal to 1/2 the product of the sides BC times the sine of the angle A. If what we're given is in the order side angle side, then the area is 1/2 the product of the sides and the sine of the angle. 1/2 BC sine A. 1/2 BC sine A. But you got to be creative here, okay? How are you going to memorize that? Side angle side. 1/2 the product of the side sine of the angle. 1/2 the product of the side sine of the angle. Because look what happens. What if what you were given was these three? It's still side angle side, but what's it going to look like? Area is equal to 1/2 the product of the sides times the sine of the angle. 1/2 BA sine C. Or what if I were given this side, this angle, and this side? It's still going to be the same. You see how you can't just memorize 1/2 BC sine A? It's side angle side. 1/2 the product of the sides, sine of the angle. Okay? The area is equal to 1/2 the product of my sides, look at the pink, AC, times the side of my angle, look at the pink, angle B. Side angle side, 1/2 the product of the side sine of the angle. Okay? If you just look at A's, B's, and C's, that's going to get a little confusing. 1/2 product of the sides sine of the angle. Okay? So if we just looked at this, it really looks like 1/2 side sine angle, doesn't it? Whatever those sides are. 1/2 the product of the sides times the sine of the angle. Now that's how I memorize it. Side angle side. 1/2 the product of the side sine of the angle. I don't know how you want to memorize it. If you want to memorize the A's, B's, and C's, that's fine. I just memorize if it's side angle side, it's 1/2 the product of the side sine of the angle. That's good for my brain. Okay? And then I plug in whatever they give me. All right. We'll do an example of that in just a second. Let everybody kind of catch up. Everybody good there? Okay, so let's see what they give me then. Whoops, I'm going to put that back. Side angle side. Okay, so number 3. Number 3, we have angle A is 28 degrees. We have that little b is 14. And we have that little c is 9. I think it helps to go to the picture, really. This is 28 degrees. B is 14. C is 9. What I've got is the green. I've got the green side angle side. And so I'm going to say that the area is equal to 1/2 the product of the sides in my side angle side. You can see side angle side there, right? Times 14 times 9 times sine of my angle, 28 degrees. Now all you got to do is punch that in. 0.5 times 14 times 9 times sine 28. Punch it in and hit enter. We punch it in and hit enter and we get 29.6. That's the area. Now if this was in inches, it would be 29.6 square inches, right? Centimeters, 29.6 square centimeters. We're dealing with the area of the triangle. Any questions on that? So if we're given side angle side and we want area, it's 1/2 the product of the sides times the sine of the angle. All right. Any questions there? All right, let's look at number 4. Have to get on to people in a sneaky way so it's not on the recording, you know. Okay, so we got angle A is equal to 15 degrees. We've got that angle B is 113 degrees. And we've got that little b is equal to 7. So we're going to stick those in our picture. We've got that angle A is 15 degrees. We've got that angle B is 113 degrees. And we've got that little b is equal to 7. Now, we've got to get this in the order, what? We've got to get it in the order of, angle, angle, side. This is the other one. I'm sorry. I jumped ships. So we're not in the angle side. We're not in the order side, angle, side now, are we? We're in the order of angle, angle, side. So we need a new rule. So let's let's get our new rule here. Let me draw the picture. So again, we've got capital A, capital B, capital C. We've got little b here, little a here, little c here. Now, let's talk about the next little rule. When what we're given is in the order of angle, angle, side. In the order of angle, angle, side. If it's in the order of angle, angle, side, then the formula for area is going to be 1/2. Now, here's the deal. I want to draw a triangle here and show you so you can see. if this is angle, and this is angle, and this is side, do you notice that this is the side opposite that angle? You notice that? That's going to happen every time. So this angle and this side are going to be opposite each other. You see that? This angle and this side are opposite each other. And the way this is going to work, we're going to say, okay, if I'm given angle, angle, side, so that I'm given this angle and this side, and then this other angle, then my key is to recognize that little a and capital A go together, okay? All right, so here's what it looks like. We're going to have 1/2 of that side square, 1/2 a squared. And then we're going to have times this crazy looking fraction. Now, whatever is right here is also going to be down there. And that's going to be sine A on bottom. And what goes on top is the sine of the other two. Sine angle B, sine angle C. So if it's in the order angle, angle, side, there will be a side that's opposite the first angle. That side is what's being squared, and that angle is what's on the bottom. And what's on top is the other two angles. Okay? So the area is 1/2 a squared sine B sine C over sine A. Okay? Understand that? And you could obviously have 1/2 B squared sine A sine C over sine B. Or you could have 1/2 C squared. But if you got C squared, then the C's on the bottom, right? If you got B squared, the B's on the bottom. If you got A squared, A is on the bottom. All right, that's the deal. Okay, so what do we have? Well, I left a piece off. What was 113 degrees there? B was 113 degrees, and little b was equal to 7. So we've got little b is equal to 7. Angle A is 15 degrees, and we've got angle B is 113 degrees. Now, is that in the order of angle, angle, side? It is. It is in the order of angle, angle, side. Let me try to show you. I'll do it in pink. We've got angle, very next angle, very next side. See that? Now, which side and angle are opposite each other? Angle B and side B. Angle B and side B were the ones opposite each other. So what's my formula going to look like? What's going to go where the little a is? That's going to be the B. And what's going to go on bottom over here? Angle B. You see that what I've got opposite? I've got the side opposite angle B. So I'm going to have the B squared and the B on the bottom. And then the rest of it looks the same. K equal 1/2 B squared. I've got angle B on the bottom, so on top I must have the other two, sine A, sine C. So you're going to have to see what you're given. It's going to be an angle, angle, side. You have to focus on which side and angle did I have opposite, and I need to set it up accordingly. And so I'm going to have that the area K is equal to 1/2 of B, which is 7 squared, times the sine of A, which is 15 degrees, times the sine of C, which we'll find in a minute, over the sine of B, which is 113 degrees. And so to get angle C, let's just kind of go ahead and start finding everything because we're solving the triangle. We've got that angle A is 15 degrees. We've got that angle B is 113 degrees, and we have that little b is 7. We're not solving the triangle. We're trying to find the area. Forget that. Sorry I did that. We'll go ahead and find C, though. Okay, C is 180 minus 15 minus 113, which is 52 degrees. So we needed to find our angle C, so we could put it right here, right, 52 degrees. So we have to focus on what did they give us that were opposites in our side angles, angle side, and they gave us the B, so the B goes here and the B goes on the bottom. And what goes on the top is the other two angles you didn't use up there. So you're going to plug that in, hit enter, and you're going to get that the area is equal to 5.4. 5.4 square, whatever the unit of measure would have been. Any questions on that? So we learned how to find some missing parts of non-right triangles when what we were given was in the order angle, side, angle, or angle, angle, side. And then we learned how to find the area of non-right triangles when what we were given was in the order side, angle, side, or angle, angle, side. To find missing parts of right triangles when what you're given is in the order of angle, angle, side, or angle, side, angle, you use the law of sines, which says sine A over A equals sine B over B equals sine C over C. To find the area of a triangle when what you know is in the order of side, angle, side, you use the formula K equal 1/2 the product of the two sides times the sine of the angle. And then if you have a right triangle and what you're given is in the order of angle, angle, side, then what you're going to do is figure out which side is opposite which angle, and you're going to say area equal 1/2 of the side that you were given squared times a fraction whose numerator is sine non-used angle number 1 times sine non-used angle number 2 over the sine of the angle that was opposite the side you squared. There you have it. All right. Appreciate your attention.